we're focusing on a critical topic for the AFOQT physical science subtest, Newton's 3 laws of motion. These laws are fundamental to physics and appear frequently on the exam, both as straightforward calculation problems and as conceptual questions designed to test your understanding. Mastering them is essential for a high score. Let's start with Newton's first law, the law of inertia. This law states that an object at rest will stay at rest, and an object in motion will stay in motion with the same speed and in the same direction unless acted upon by an unbalanced external force. On the AFOQT, this is almost always tested conceptually. Imagine a question describing a satellite moving through the vacuum of space. If its engine's cut out, what happens? It continues to move at a constant velocity. That's inertia. A common trap is to think that motion requires a continuous force. The exam might present a scenario where a box is sliding across a frictionless surface at a constant velocity, and ask what force is required to maintain that state. The answer is zero net force. An object in motion stays in motion. Next is Newton's second law, which is the most frequently tested of the 3, often requiring a calculation. The formula is force equals mass times acceleration, or F equals ma. An exam question might state, a 10-kilogram object is accelerated at 5 meters per second squared. What was the net force applied? You simply multiply the mass by the acceleration. 10 kilograms times 5 meters per second squared equals 50 newtons. The key here is to be meticulous with your units. Mass must be in kilograms, acceleration in meters per second squared, and the resulting force will be in newtons. A classic AFOQT trick is to give you the weight of an object instead of its mass. For instance, the problem might mention a 98 Newton object. You must first convert this weight to mass by dividing by the acceleration due to gravity, which is approximately 9.8 meters per second squared. So, 98 newtons divided by 9.8 gives you a mass of 10 kilograms, which you would then use in the F equals ma calculation. Finally, we have Newton's third law. For every action, there is an equal and opposite reaction. This law describes how forces always occur in pairs. If you push on a wall, the wall pushes back on you with the same amount of force. The AFOQT will test this with conceptual questions. A typical example involves rocket propulsion. A rocket moves forward by expelling gas backward. The force on the gas is the action, and the force on the rocket is the reaction. The test makers will try to trick you with wording that implies one force is greater than the other. Remember, the action and reaction forces are always equal in magnitude and opposite in direction. To help keep these laws straight on exam day, use the mnemonic in Marie. First is inertia. Second is mass times acceleration, or ma from the formula F equals ma. Third is reaction, for the action-reaction pairs. By breaking down each law and anticipating how it will be tested, you can confidently tackle these physical science questions. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.